Welcome to GeoVerse Lab, where geography comes alive, science makes sense, and every corner of our planet has a story to tell. Explore the Earth, discover fascinating facts, and see the world like never before. Have you ever picked up a small stone from the ground and wondered how old it really is? It may look like an ordinary piece of rock, but that tiny stone could be millions of years old. Some rocks were born inside powerful volcanoes. Some were once tiny grains of sand at the bottom of ancient oceans. And some were transformed deep beneath the Earth's surface by incredible heat and pressure. But here's a question. What exactly is a rock? And how is it different from a mineral? Most people think they're the same thing, but they're not. In today's video, we're going to uncover the amazing story hidden beneath our feet. You'll learn what minerals are, how rocks are formed, the three main types of rocks, and finally, we'll explore the incredible rock cycle that has been shaping our planet for billions of years. So, let's begin our journey. What is a mineral? Before we understand rocks, we first need to understand minerals. Think of it like baking a cake. You can't bake a cake without flour, eggs, sugar, and other ingredients. In the same way, you can't have rocks without minerals. Minerals are the basic building blocks of rocks. But not everything is a mineral. A mineral must follow a few simple rules. First, it must be made naturally by nature. Second, it has never been alive. And finally, its atoms are arranged in a very organized pattern called a crystal structure. Because of this special arrangement, many minerals grow into beautiful crystals with unique shapes. Some minerals are shiny like gold, others are transparent like quartz, and some are colorful like amethyst. Every mineral has its own unique appearance. How do scientists identify minerals? You might be wondering, if there are thousands of minerals on Earth, how do scientists tell them apart? Geologists look at a few simple characteristics. The first is luster. This tells us how a mineral reflects light. Some minerals look shiny like metal. Others have a glass-like appearance. Next comes the streak. Instead of looking at the outside color, scientists rub the mineral on a special plate to see the color of its powder. Sometimes the powder is completely different from the mineral itself. Another important property is hardness. Some minerals are so soft that you can scratch them with your fingernail. Others are incredibly hard. In fact, diamond is the hardest natural mineral found on Earth. These simple tests help geologists identify almost any mineral. What is a rock? Now that we understand minerals, let's talk about rocks. A rock is simply a combination of one or more minerals. Think of minerals as Lego bricks. A single Lego brick isn't a house, but when many bricks join together, they create something much bigger. Rocks work exactly the same way. Take granite as an example. It may look like one solid stone, but if you look closely, you'll see different colors. The pink parts are feldspar, the white or glassy parts are quartz, and the black spots are mica. Together, these minerals form one rock called granite. The three main types of rocks. Although there are thousands of different rocks, scientists divide them into just three main groups. These are igneous rocks, sedimentary rocks, metamorphic rocks. Each one has a completely different story. Let's look at them one by one. Igneous rocks. The word igneous comes from a Latin word that means fire, and that's exactly how these rocks are formed. Deep inside the Earth, the temperature is so high that rocks begin to melt. This melted rock is called magma. But when magma escapes through a volcano and reaches the Earth's surface, we call it lava. Now here's something interesting. Not all igneous rocks look the same. It all depends on how quickly the magma cools down. If magma cools very slowly beneath the Earth's surface, large crystals have enough time to grow. This creates rocks like granite, where you can clearly see different minerals. But if lava cools very quickly after a volcanic eruption, there isn't enough time for crystals to form. Instead, it creates rocks like obsidian, which looks like shiny black glass. Another fascinating example is pumice, because it forms from lava full of gas bubbles. It becomes so light that it can actually float on water. Isn't that amazing? Sedimentary rocks. Earth's history book. Now let's move to the second family of rocks. Sedimentary rocks. Unlike igneous rocks, these aren't born from fire. They're created by time, water, and pressure. Imagine a huge mountain over thousands or even millions of years. Wind, rain, rivers, and ice slowly break that mountain into tiny pieces. These tiny pieces are called sediments. Rivers carry these sediments into lakes and oceans. Slowly, they settle at the bottom in layer after layer. As more layers build up, the weight becomes heavier. The lower layers are squeezed tightly together. Natural minerals act like cement. And over millions of years, loose sediment turns into solid rock. That's how sedimentary rocks are formed. Some common examples are sandstone, shale, and limestone. But here's the most exciting part. Sedimentary rocks are the only rocks that contain fossils, ancient shells, dinosaur bones, plant leaves, even footprints. All of these can be preserved inside sedimentary rocks. That's why geologists often call them Earth's history book. Every layer tells the story of a different time in Earth's past. Metamorphic rocks. Rocks that changed their identity. Now let's explore the third and final type, metamorphic rocks. The word metamorphic simply means changed form. These rocks weren't created from magma, and they weren't formed from fresh sediments either. Instead, they started their lives as igneous or sedimentary rocks. Then something incredible happened. Over millions of years, they were buried deep beneath the Earth's surface. There, they experienced extreme heat and enormous pressure. But here's the important point. They don't melt. If they melted, they would become igneous rocks again. Instead, they remain solid. But their minerals slowly rearrange themselves. The rock becomes stronger, harder, and completely different in appearance. For example, ordinary limestone changes into beautiful marble, and soft shale transforms into hard slate, which is commonly used for roofs and tiles. Nature has completely changed the rock without melting it. The rock cycle, Earth's endless recycling system. Here's the most fascinating part of all. Rocks don't stay the same forever. Our planet is constantly changing them. Scientists call this process the rock cycle. Imagine an igneous rock sitting on a mountain. Over time, rain and wind slowly break it into tiny pieces. Those pieces become sediment. Eventually, they form sedimentary rocks. Later, those sedimentary rocks are pushed deep underground. Heat and pressure transform them into metamorphic rocks. If those rocks sink even deeper, they melt into magma. When that magma erupts from a volcano, it cools and becomes a brand new igneous rock. And then, the entire cycle begins all over again. This incredible recycling process has been happening on Earth for more than 4 billion years. So today we've discovered that minerals are the building blocks of rocks. Rocks are divided into 3 main types: igneous rocks, born from fire; sedimentary rocks, formed by layers of sediment over time; metamorphic rocks, changed by heat and pressure. And all of them are connected through the amazing rock cycle, a natural process that has been shaping our planet since the very beginning. The next time you pick up a simple stone from the ground, remember, you're not just holding a rock. You're holding millions of years of Earth's history in your hand. If you enjoyed this video and learned something new, don't forget to like, share, and subscribe to Geoverse Lab. Thanks for watching. And I'll see you in the next video, where we'll continue exploring the incredible story of our planet.